All right, so peace, kings and queens. So we're going to go ahead and jump back into our flipped classroom videos. The next part of our unit is very, very important. So I want you guys to make sure that you take your time while we're going over our notes, that we make sure that we really, really understand what's going on. So if you look at our topic and objective, it says that we want to solve a system of equations by graphing. So my essential question is, how do I solve a system of equations by graphing? So as usual, let's go ahead and start off with some vocabulary. So if we look at the first part, I want to know what a system of equations is. So a system of equations is going to be the formation. So it's going to be the formation of two equations. Okay, the formation of two equations. So if I look at the first part, it says the ordered pair that is a solution of both equations is the solution of the system. And that'll make a little bit more sense when we look at our examples. It says a system of two linear equations can have one solution, an infinite number of solutions, or no solution at all. And we're going to look at each specific case. Okay, if we continue on, it says if a system has at least one solution, that means it is said to be, the word is going to be consistent. So if my system has at least one solution, it's going to be consistent. If a consistent system has exactly one solution, that means it's going to be independent. So if it only has one solution, it's going to be independent. Okay? Independent. If it has an infinite number of solutions, it is going to be dependent. So if it has an infinite number of solutions, it's going to be dependent. This means that there are an unlimited solutions that satisfy both of the equations that are going to be in my system. So if I keep moving on, it says if a system has no solution, if a system has no solution, it is said to be inconsistent. If a system has no solution, it is going to be inconsistent. And that means that when I graph my two equations, they're going to be parallel lines. If a system is inconsistent, that means it can't be dependent or independent at all. Okay? So let's jump down to our first example. It says we want to graph each system and determine the number of solutions and name it. Okay? Also state whether each system is consistent, inconsistent, or independent and dependent. Okay? So if I look at Part A. So we all know how to graph things in slope-intercept form. And just as a review, slope-intercept form is going to be y equals mx plus b. Okay? We want to make sure that before I graph that my systems are in slope-intercept form. And if I look at both of my equations, they are. So I'm going to label my equations when I'm doing my problems. This is going to be equation 1, and then this is going to be equation 2. So if I'm looking at equation 1, I have y equals 3x plus 10, okay? Remember, the first ordered pair that I'm going to graph is the y-intercept. If I look at this problem, my y-intercept in this problem is going to be 10. Remember, when I'm graphing a y-intercept, the x is always going to be equal to 0. So let's go ahead and graph that first order pair. I should have 0, comma 10. So that first order pair is going to be right here. So I have 0, comma 10. Now remember, I need to use the slope, which is in this case 3, to find my next point. Okay? So in order to find the slope, I'm sorry, in this case it's negative 3. So that means, remember, slope is equal to rise over run. So that means that I'm going to fall 3. So I'm going to count down 1, 2, 3. And I'm going to run a positive distance, just 1, because this is the same thing as negative 3 over 1. Okay? So remember, 2 points determine a line, so that means that I can draw the line of my equation like we've been doing just as normal. So now let's go ahead and move to the second equation. If I look at the second equation, I have y equals x minus 2. So same as before, the first thing that I'm going to graph is my y-intercept. If I look at this equation in slope-intercept form, my y-intercept is going to be negative 2. So once again, whenever I'm graphing the y-intercept, x is always going to be equal to 0. So if I do that, let's go ahead and plot that point. And that point is all the way down here. And then once again, I'm going to use my slope to graph the next point. Okay? So my slope in this case is going to be the number in front of x, which is 1. So that means I'm going to rise 1 and run 1. Okay? So if I look at these 2 points, remember 2 points determine a line. So I can tell that these 2 lines are going to intersect. But remember, the purpose of solving a system is to know where they intersect so that I can find a solution. So just so I can be certain, I'm going to keep graphing more points. So remember, I used my slope in equation number 2, which was 1. So let's keep using that. So I'm going to, from the second point that I graphed, I'm going to go up 1 and run another one. All right, still going to keep going up 1 and running 1. And now I can see where my 2 lines intersect. Now the solution to your system, if we look back at the top, is going to be the point where my lines intersect. So the ordered pair where my lines intersect looks like it is going to be at 3, comma 1. And that is the solution to my system. Okay? That is a solution to my system, the ordered pair where they intersect. Now, if I go back to the directions, it also asks me to determine whether or not it was consistent or inconsistent and independent versus dependent. So my definition for something being consistent is that it has at least one solution. So my graph intersected at one point, so that means it has at least one solution. So it's definitely going to be consistent. Okay, so let's go ahead and write that. It is consistent. And then last but not least, it also asked me whether or not it was going to be independent or dependent. So if a consistent system has exactly one solution, it's going to be independent. And because it only has one solution, this system is also independent. Okay, so let's keep moving. Let's go ahead and flip that page over. Okay, so if I look at part B, we're still going to keep continuing to do the same thing. Now part B is a little different because if you notice, I don't have my equations in slope-intercept form. So this is where all that stuff is coming back into play. I have to be able to manipulate my equations in slope-intercept form. So once again, I'm going to go ahead and label the first one, and then I'm going to label the second one. So let's do this. Let's try to manipulate the first one. And I have 2x minus y equals negative 1. So remember, when I'm putting things in slope-intercept form, I want to solve for y in this case. So remember, we're imagining that this is a random two-step equation and that x is just imaginary. So if I want to solve for y, I'm going to subtract 2x on both sides. So 2x minus 2x is 0 because these cancel. Then I'm left with negative y equals, I cannot combine negative 2x and negative 1 because they're not like terms. So I'm left with negative 2x minus 1. Now I'm almost done, but my equation is not in slope-intercept form yet. So now I have to divide by negative 1 to every single term. It is very important that when you're doing this, you pay attention to your sign. So I'm going to be left with y equals a negative 2 divided by a negative 1 is positive 2x. And then negative 1 divided by negative 1 is going to be positive 1. So I have my first equation. Okay? So I want to go ahead now and manipulate my second equation. When I manipulate my second equation, I have 4x minus 2y equals 6. So just like I did in the first thing, I'm going to subtract 4x from both sides. 4x minus 4x cancel, that's 0. I'm left with negative 2y equals negative 4x plus 6 because they can't be combined. I need to divide negative 2 on both sides. So I'm going to be left with y equals negative 4 divided by negative 2 is positive 2x. Positive 6 divided by negative 2 is negative 3. So now if I look at my two equations, they're both in slope-intercept form. So now I can graph them and determine whether or not I have a solution. So now that I have my two equations, I can go ahead and plot these points. So if I go back to equation 1 in red, I have y equals 2x plus 1. So the first point I'm going to plot is 0, 1. 0, 1, okay, because 1 is my y-intercept. And then my slope is 2, so I'm going to go up 2 and run 1. So that's the first line that I have. And then I'm going to go ahead and graph the second equation. When I graph the second equation, I'm going to graph 0, negative 3 first. Okay. And then my slope is also 2. So I'm going to go up 2 and over 1. And that's that line. So if we pay attention to the two lines that I have, they don't intersect at any point. They're actually parallel to each other. Okay? So in this case, there is no solution. So whenever my lines do not intersect, it is no solution. If I look back at my equation, though, there's a note. So if I look at my equation, my slopes are the same. So when the slope is the same, and there are different y-intercepts, the lines are parallel. So the lines are going to be parallel. Okay? If I keep going and looking at part C, I have one equation, my first equation is already in slope-intercept form. And then I have my second equation. So my first one is y equals 2x minus 3. And then I'm going to graph that first. I have 0, negative 3. Once again, my y-intercept is negative 3. My slope is 2, so I'm going to go up 2 and over 1. And this is the line that I have. And then if I go to equation 2, I have 6x plus 3y equals negative 9. So I'm going to solve this to put in slope-intercept form. So I'm going to subtract 6x from both sides. These cancel. I'm left with 3y equals negative 6x minus 9. But hold on, let me go back. I actually did that wrong. So if I look at this first equation, this is supposed to be negative 2x minus 3. So my first point is down here, 0, negative 3. And I'm going to go down 2 and over 1. So this is the actual line I should have. That's the line I should have. Okay? Pay attention to the sign because clearly my line is completely different. So now if I go back to my equation, I was finished solving this one, and now I need to divide by 3 on both sides. And when I simplify, I'm going to be left with y equals negative 6 divided by 3 is negative 2x. Negative 9 divided by 3 is negative 3. Now, if you pay attention, I get the exact same equation that I get in my equation for number 1. So if I were to go back and graph it, it would be the exact same line. So in this case, that means that my system of equations has infinite solutions. I have infinite solutions. I have infinite solutions because it's the same exact line. Any line that is on that point is a solution to my system of equations. So that pretty much sums it up. Remember, what I want you guys to do is you guys are writing questions on the front and the back, and also coming up with summaries for the front and the back. In addition to that, for examples B and C, I want you guys to determine whether or not you can figure out if your system is consistent or inconsistent and dependent versus independent.